special segments in circles. Okay, we've already done some tangent, secants. Okay, this one, theorem 1015, says if two chords intersect in a circle, then the products of the measure of the segments of the chord are equal. Okay, so look at this picture. Okay, CE. Okay, find CE right here. CE times ED equals AE times EB. Okay, so now fill in. CE is 8. ED is 3. Their product has to equal the product of AE, which is Y, and EB, which is 2. So 24 equals 2Y. If you divide by 2 on both sides, Y has to equal 12. Okay? So if two chords intersect in a circle, the products of the measures of the segments of the chords are equal. Okay? Okay, and that's an example of it. Okay, theorem 1016. If two secant segments, okay, remember secants, it's a secant line if it cuts the circle. If it just touches the circle, it would be a tangent. If two secant segments are drawn to a circle from an exterior point like E, the product of the measures of one secant segment. Now, this part right here, the measures of one secant segment, that's the whole thing. That's that whole thing. Okay? And its external secant segment, that's this part right here. Okay? So, on this EH times EI. EI is the whole thing. Okay? Times the EH. Okay? And it's equal to the product of the other thing, so that's the whole thing, EG, times that secant, external secant part. Okay, so on this EH would be 8. EI would be what? 8 plus X. EF is 10, and EG is the whole thing, 34. Right, it's that whole thing. Okay, so you got to add this whole thing. Yep. Okay, so you can distribute this, or you can divide. If it's divisible, which I want to check. Okay, if I go ahead and multiply this out, I'd get like 340. If I can divide this by 8 and divide this by 8, I don't have to distribute that. So 340 divided by 8. Will it go in there evenly? No. $42.5. And those would reduce, and I'd have 8 plus X. Subtract 8 on both sides. And X would equal. Now, the way I'm showing you here is not the only way to work that. You could distribute the 8. You could distribute that out and say that'd be what? 64 plus 8X equals 340. I could subtract 64 on both sides and then divide, what is it? 276, and then divide that by 8. Do I get the same answer? Better. 34.5. So your steps don't have to agree with mine, but your final answer should be 34.5. So on this one, if you have two secant segments, okay, it's the whole thing. Okay, so you got to figure out what that whole thing is. It's 8 plus X times this exterior part, and then it's this whole thing. So you add those two together. That'd be the 34 times the X, just that exterior part. Okay. Any questions on that one? Okay, then theorem 1017. If it's a tangent segment and a secant segment are drawn to a circle. Okay, this one is the tangent because it's just touching the circle. This one is the secant because it cuts the circle. It says if a tangent and a secant are drawn to a circle from an exterior point W, then the square of the measure of the tangent segment. So you square the tangent segment. So you got to square this, okay? Equals the whole thing, the WY, times the exterior part. Okay, so sub in. So we'd have A plus 4 quantity squared. The WY is the whole thing. Combine like terms, what are you going to get? Yep, 2A plus 2. And then WZ, the exterior part, is just A. Right? Now, we talked about this last week. The critical part about squaring a binomial is that you end up with a trinomial square. Shortcut is square that first term, A squared. Multiply these two terms together, would be 4A, and double it. Okay? So that'd be 8A. And then square the last one, would be 16. Now, if you don't like doing it that way, then you can write it out this way and FOIL it or draw the arrows and then combine the like terms, and that's what you'll end up with. Okay, multiply this out would be, and when you multiply, you add the exponents. So it's 2A squared plus 2A. Okay, now I recommend you keep the A squared term positive. You need to get it in standard form equal to 0. I could subtract the A squared, or I could subtract the 2A squared. I want to try to keep the A squared positive. So I'm going to subtract 1A squared on both sides. I'm going to subtract the 8A on both sides. I'm going to subtract the 16. Okay? So this whole thing goes to 0. And then I'm down to A squared. Okay? What, minus 6A? Minus 16. Now you have factoring. I always try factoring first. There's nothing in common. Then I go to two sets of parentheses. I know I need an A and an A. This sign tells me that the signs are different, because when I multiply them together, I need a negative 16. So I need one positive, one negative. They have to multiply together to give you 16. And if this is a minus sign, you say they differ by 6. And this is the sign of the larger one. 8 and 2, and the 8 goes with the minus sign, and 2 goes with the plus sign. Okay, so then you set 0 equals A plus 2. So A would equal negative 2. And 0 equals A plus 8, or sorry, minus 8, minus 8. And then you need to add 8 on both sides. A minus 8. So if you add, you'd have A equals 8. Can this A be negative in that picture? No. So you accept this one, you reject this one. Okay, just reject that one. Okay. Okay, any questions on that one then? Another example on the back. Okay. Okay, it's the tangent one that's squared. Okay. And it's times the whole thing. So you got this whole thing times this part. Okay. So the tangent one is squared. So it's the AB. So it's 4 squared equals the whole thing, which was BD, would be what, 2x plus 2? And the BC would be just x. Just add 1x plus 1x, be 2x. You got to combine the like terms. You're not multiplying them, you're adding them. Okay? And then the BC is just x. Okay? So we'd have 16 equals, multiply this out, would be 2x squared. Multiply this out, would be 2x. Get it in standard form equal to 0, subtract 16. Take it over to the other side. So you'd have 2x squared plus 2x minus 16. What's in common all the way across? 2. Take that out. Factor it out. If I do this, if I take a 2 out, I have x squared plus x minus 8. Now, if I divide by 2 on both sides, it's gone, right? So 0 equals x squared plus x minus 8. Now, if I look at the factoring part, I need two numbers that multiply together to give me 8 and differ by 1. No such animal, okay? So, quadratic formula. This one you're forced. You got to do the quadratic formula. On this, remember it's in the form 0 equals ax squared plus bx plus c. So my a is 1, my b is 1, my c is negative 8. Okay? Quadratic formula, remember the lyrics to the song? X equals negative b. B squared minus 4ac. B squared minus 4ac all over 2a. There you go. Okay? Okay. When you do this, don't do simplifying. Just sub in, then simplify on the next step. People try to do too much at once. Just be opposite of b. Plus or minus the square root. 1 squared minus 4 times 1 times a negative 8. And it's all over 2 times 1. So it'll be negative 1 plus or minus 1. And then negative 4 times a negative 8. Positive 32, and it's all over 2. X equals negative 1 plus or minus the square root of 33. And it's all over 2. Now when you do this on the calculator, you got to make sure you have parentheses around this. The easiest way on the calculator is just do the parentheses, do a negative 1 plus the square root of 33, close the parentheses, divided by 2. Okay? And I get 2.37. This one we're just going to go to the nearest hundredth. Okay, then do second function entry right above the enter key. Let it retype over that. Now come back over here and do the minus. Just type over that minus sign. So you don't have to retype the whole thing. Second function entry is right above enter. Okay, so a negative 3.37 if we round it to the nearest hundredth. Can the x up here in this picture be negative? No. So you reject this. This is our final answer. Okay? So, do you have to have this memorized? Yes. Quadratic formula. That anytime you have a squared term as your highest term, you try factoring, then quadratic formula. Algebra 2, you get completing the square. Most people are going to go to this one. Okay? So our final answer is 2.37. Okay? That should get you started.